Let's take a look at question 1 from our periodic function activity. On this one, we are provided with a graph of a function that is periodic, and we are asked to identify some of the key characteristics and find some points along our function using sort of our knowledge of periodic functions. So step 1, we want to find the period of our function. So to do this, I recommend finding a max or a min value. It's just the easiest sort of way to see where the pattern repeats. In this case, I'm going to go straight for that max because they're right there in front of me. And so we want to know how far apart these are. And on a graph, you could count. We could also use some, algebra because this is at 2 and the max is back there at 12. So you could go 12 minus 2 with a period of 10. I could have also counted either way. I like to label the features on the graph. It's a personal thing. Now, knowing the period, it's pretty easy then to get the frequency. So I know if the period is 10, the frequency is going to be 1/10, of a period, so like 1/10 of the period per input. All right, now in this case, we now also need to find the midline and the amplitude. I'm going to switch colors here. So if I want to find the midline is going to be halfway between our min and our max. And so our min here occurs at 1, and our max seems to occur at 7. So, that's a 7, I can do 7 plus 1 divided by 2. 7 plus 1 is 8 divided by 2, that's 4. And so I would expect my midline to be at y equals 4. Don't forget that it is an equation. I could also sort of, look a little bit and, do a little bit of counting here on the graph. 2, 6, 5, 3, 4 is where those two sort of amounts would meet. And I could draw in my midline right here. I like to have my sort of key features labeled. Midline, y equals 4. Amplitude then is going to be the distance between, oops, I already used purple, that amplitude or that midline and our minimum. Or you could think of it as our maximum and the amplitude, and the midline. And again, I'm just going to count on the graph. So we have 1, 2, 3. 1, 2, 3. So they agree, great, that's important. We want to make sure that they do. Amplitudes don't have any special symbol in front of them, unlike the midline. Amplitude. All right, so we have our 4 key features. Now next we're going to do a little bit of function notation practice and think about our definition of periodic functions. So first off, we're given the point f of 10. All right, so f of 10, at 10, where is our function? Well, it's right, oops, my pen doesn't seem to want to work. Come back. It's right, oh, now my pen is working. It's right here. There's 10, my input of 10, and that is occurring at 5. Now, I'm also asked to find f of 20, and if I look here carefully, f of 20 isn't on my graph. My graph sort of goes up to about 18 here. But if I look here closely at my input values, 20 minus 10 is 10, which is my period. So this is basically 1 period later. I've added a period amount. And so if I've gone 1 full cycle, I should be back at where I started, which would be 5 again. All right, looking at the graph, find 2 x values when f of x equals 1. So this is basically, I want to find sort of points on my graph where I have those minimum values. And I'm going to use black. So I have 1 here, and I have 1 here that are shown on my graph. And so 1 is at x equals 6, and I have another here at x equals 16. So, I wrote them as x equals 6 and x equals 16. You could think of it as f of 16 equals 1, if that sort of helps you think about it. Now that I have these 2 values, let's find 2 more times when f of x equals 1. It's not shown on the graph, but remember, we're sort of going off this idea that every time the period occurs, I would hit that value of 1 again. So if I wanted the next point along sort of on the positive side, I could say, okay, well, we're starting at 16, but if I go one more period amount, I would end up at 26. So I know that f of 26 should also equal 1. And I can work this backwards as well. So, I want to go back this way. When am I going to be back at 1? Well, if I start at 6, I'm going to subtract a period value. So I'm sort of minusing the period. And I would end up at -4. And so f of -4 also equals 1. And I could keep going. But this is sort of a quick, like, okay, I found 2 more times using my period and my understanding of it to figure out where the next points are. Now that you've sort of seen the first problem, maybe try the next problem on your own. But if you get stuck, take a look at the video.